Our discussion of reflection and rotation is going to be quite a bit shorter because we're only going to discuss 2 reflections and 1 rotation. We're going to talk about reflection across the x-axis, for which we negate the y-coordinate. We're going to talk about reflection across the y-axis, for which we negate the x-coordinate. And we're going to talk about rotation by 180 degrees around the origin, for which we negate both coordinates. So, in this example, starting with F, we reflect across the x-axis to get H. We reflect across the y-axis to get K. And we rotate 180 degrees to get L. So let's see how this actually plays out. Looking at the key points again, F has 4 key points. 2, 4, so f of 2 is 4. 5, 6, so f of 5 is 6. 6, 1, so f of 6 is 1. And 8, 3, so f of 8 is 3. To go from F to H, we're negating the y-coordinate. So 2, 4 becomes 2, negative 4. So H of 2 is negative 4. 5, 6 becomes 5, negative 6. So H of 5 is negative 6. 6, 1 becomes 6, negative 1. H of 6 is negative 1. 8, 3 becomes 8, negative 3. So H of 8 is negative 3. Our inputs stay the same, and our outputs are the opposite. Well, it looks like we're just negating the y-coordinate. So h of x is the opposite of f of x. Okay, that was the vertical version of this reflection. What we're doing to get k must be the horizontal version of this reflection. So 2, 4 becomes negative 2, 4. Five, 6 becomes negative 5, 6. 6, 1 becomes negative 6, 1. 8, 3 becomes negative 8, 3. So the outputs are staying the same. And we're taking the opposite of the input. So to take k of negative 2, we took f of 2, for example. Now, we're doing something horizontal, so we expect we need to undo whatever we wanted to do to the x-coordinate. But to undo taking the opposite, we just take the opposite again. So this one is actually just as easy as the vertical one, because taking the opposite again undoes taking the opposite. Okay, what about this rotation? The rotation is a little bit weird, but I think we can see it. The point 2, 4 comes around to the point -2, -4. The point 5, 6 comes around to the point -5, -6. The point 6, 1 comes around to the point -6, -1. The point 8, 3 comes around to the point -8, -3. The easiest way to see what's going on here is if I draw a straight line connecting a corresponding pair of points. That passes right through 0, 0. And a straight line, that's 180 degrees. So that's what's going on with that 180-degree rotation. So what we see here is that the output is the opposite, and the input, well, that's also the opposite. So we have to undo taking the opposite. Well, that's taking the opposite again. Then we do F, and then we reverse the sign on that. So that 180 degrees is actually two changes. It's actually the other two put together. If we take the opposite inside the function, that's a reflection across the y-axis, a horizontal reflection. If we take the opposite outside the function, that's a reflection across the x-axis, a vertical reflection. And if we take both opposites, then we're rotating around the origin. Remember, we reflect across a line. We rotate around a point. Notice that this point is the point where the two lines intersect. That's not a coincidence. The rotation is the combination of both reflections. You might remember from a geometry course that if you want to get a rotation, you can do it by combining two reflections. And that's what we see here. So these three just involve changing the sign, and they're actually really straightforward to work with.